Thank you everyone for being here. My name is Steele. I'm a principal at one of the principals at Sitka Technology Group. We're a firm here in Portland, Oregon. We do lots of environmental data management, systems work, that sort of thing. And I have with me Mr. Chris Dean, who is a technical lead on one of our product teams, who's going to be helping me with some demonstrations that we're doing in the second half, since I can't see the things at once. So again, we're happy to be back. We were here a couple years ago with Iot Devices, our tablet data collection software. We did a field trip, so some of you may remember that. We're not doing any of that today. We're going to be focusing more on the back end. So I spent my entire career in technology and had a great time working with lots of talented people. Very fortunate to link up with Brian Mills, who's in the audience here, and Matt Ediston. We formed the company in 2008, and we've been focused on the environmental sector ever since, and it's been a lot of fun. So our talk today is going to be about, it's going to be in two halves. We're going to talk about just knowledge management in general, and some of the trends that are going on, and how the cloud might be able to help you do that. So with the field trip we did 2 years ago with Geooptics, that was a cool field trip, but it's just another data collection app. There's dozens of those out there. Many of them are free, very inexpensive, and so I was putting together this presentation. I'm like, is data collection really actually the thing that matters if you want, right? Is that, I mean, it certainly matters to people who are doing it, but there are a lot of bigger problems out there. And the work that we do with our clients, we see time and time again that getting the right data to the right people at the right time, consistently across the organization, is difficult or actually impossible in many cases. So over the past 10 years, right, we've seen an explosion in technological advances in terms of data capture, storage, analysis, synthesis, and collaboration. And it's been like wildfire, so we'll show you some of that here today. But in our industry, the folks that we're doing natural resource management, it always seems like when we are working with clients, we're still engaged in spreadsheets and PDF documents and files that are on servers behind firewalls that no one can get to. And if you're lucky, you might have a website where you can share some of that data, but it's not standardized and it's not well done in most cases. So just like playing a game of chess without a game strategy will likely lead to you playing like I do. You're getting your using a lot of chess games. We want to make sure that we're going to be developing systems and strategies that we that deliver information to the right people at the right time. We want to make sure that that's based on a solid foundational framework that aligns with your organizational objectives. So what we're going to talk about today is a little bit of kind of basic KM knowledge management theory, and we'll get into some bright, shiny new things in terms of the cloud technologies, but that's what we'll talk about. So that's our agenda. Okay, so really quickly, KM is a strategy that's really concerned about making relevant information and this term called actionable intelligence available to those people that need it, when they need it, and in the form that they need it in order to be able to make the decisions. You can make it actually effective data-driven decisions across the enterprise. So information is relevant when it's valuable. And we mean that it's valuable when it contributes something to the quality of the decision that you're making. And if information doesn't actually contribute, but it is additive to the decision that's at hand, it's actually in the way. Right? So understanding what is in the way and what is actually additive is sort of like a key element of the study of knowledge management. Another term they bounce around in this field is intelligence. And what we talk about is intelligence is the application of wisdom and the generation of knowledge that can be used in the formulation of specific strategies and tactics to accomplish the goal. Intelligence is actionable when in and of itself you can make a decision depending on the course of action. So, So to build a knowledge management strategy, you've got to think carefully about the fundamental mission of your organization, the strategic context in which it operates. You've got to understand what are the strategic decisions the organization must take, who must make them, what information and data is required in order to make them. If you're one of those rare organizations that can do all of that, the other question you have to ask yourself is, do your IT systems and structures and processes actually align with those goals? Because it's often one thing that, yes, we know how we want to be making these decisions, we know the data, but then our IT systems are just a mess. They don't actually align with that, they don't understand with it. Procurement and development is just a miss. So I'm all about alignment and strategy as well as implementation. I think you can make those two work together, you're much more likely to be successful. So this is before we're going to do a talk on knowledge management. We have kind of this classic thing we have to tip our hat. This is fairly standard. So we have data being the first. Yeah. So data is essentially the discrete objective facts about what we're gathering information about, such as who, what, when, where. Data in and of itself is not very useful. You can't make decisions on it. The next rung up the hierarchy is information, which is separated from data, and that is useful and relevant for decision making, and it's inferred from the process of answering and interrogative questions like who, what, how, when, and why. This combinations of data that relate to each other through some context proves valuable in decision making. Next up the ladder is knowledge, which actually gets to the why and the how about something, provides a deeper level of insight on the subject matter that you're studying, and then ultimately this thing called wisdom, which is sort of hard to grapple with. The example I use often is discovering that you have a computer algorithm that is used to detect patterns in light distortion and disruptions, but you can also maybe apply that to producing sound. So it's this notion that you can apply knowledge that's gained in a non-intuitive manner into other fields. So that's sort of the 101, and that's been a theory. And actual practice, this is more what it looks like for most organizations. We have a lot of data, stockpiles of data, but oftentimes it's incomplete in ways that we don't fully understand, sometimes in critical ways. And we don't have widespread tools for disseminating knowledge and allowing other people to see it and discover it. This model was built in the 1980s, late 1980s, and we haven't really had that technology at the revolution at that point in time, so there's been a lot of revisiting of this model recently, and this is the one that's sort of replaced it. This diagram is from Murray Jennings' paper titled Big Data, the Internet of Things, and the Revised Knowledge Pyramid. We don't have a lot of time. We don't have enough time to go through all of this in detail. This is a subject in and of itself. I'll refer you to the paper if this is interesting to you, but just definitely wanted to drill in on some of the big data, IoT, and other sensors, since that is sort of the topic of this conference. And it does have an impact. It has such an impact that Murray felt like he needed to revise the knowledge pyramid to account for it. So before we get too much further, I've just got a few big data facts, kind of fun facts for you. So IoT devices, which are the Internet of Things, these are the things that sit in your home, they sit in your car. These are all the little the web-enabled things which allow things to be instrumented in your life. That is growing at a fantastic rate. By the year 2020, they forecast there's going to be 20 billion IoT devices deployed worldwide, far more than all of the cell phones and computers in the world. So this piece of the industry is going to dominate over the next several years. McAfee in 2012 actually estimated that big data was being created at 2.5 exabytes a day. 1 exabyte is 1 billion bytes, or 10 to the 18th power. And that was 5 years ago. In 2015, Forbes reported that more data had been created in the previous 2 years than the entire previous history of the human race. And by the year 2020, about 1.7 megabytes of data will be created every second for every man, woman, and child on the planet. And so our accumulated digital universe, all things that we know that are digitized, will grow by 2020 to about 44 zettabytes. Now, we don't often deal in zettabytes, but a zettabyte is 1 trillion gigabytes. So that gives you an idea of what's out there. Equally astonishing, according to the experts, less than 0.5% of all of that data is being analyzed in any way. It's being accumulated on hard drives, making firms like Hitachi very, very wealthy, and no one's actually ever looked at it. Why is that? The big data is large, right? Most of it's structured, and it cannot be analyzed without the aid of new tools. It cannot be analyzed in the way that we've always thought about it, in R or in spreadsheets or whatever. It requires a fundamental rethinking of dealing with it, and the data is coming in so big and so fast that you actually need machines and data science to process it and distill it down to where it's actually useful. And our ability to capture data and store it is far surpassed our ability to analyze it and do something with it. So there's this vacuum gap in the industry right now, like the statistics as you can see. And we believe, as a company, and I believe personally, that over the next several years, that gap will close. All right, so we're not going to walk through all of the details. The slide deck will be available to you, but if you're interested in developing a knowledge management strategy that you can then build systems and alignment around, there's a few things that you can worry about, or steps they suggest that you should undertake as an organization. Not surprising, but they involve being very thoughtful about the types of decisions that you need to make, who needs to make them, and what data and information you need at various levels of the organization to be able to get to that. And then once you have that understanding, all you got to do is get your systems aligned and voila, do that. All right, so it's demonstration time. We're going to do a little time check, make sure that we're doing okay. I think we're doing perfect. So we got 4 different things we're going to show you today. We have an IoT demo. We have the best of intentions of showing you an IoT demo, and I'll get into that in just a second. So we're starting at the bottom of the pyramid, kind of working our way up that knowledge pyramid, if you will. We've got a demo that hopefully Chris will be able to get to work on doing some cloud-based analytics on data that we've captured in Optics, and we'll give you a little bit of demonstration about that. And we're going to do some analysis, visualization, and knowledge sharing demos with a tool called Power BI. It's actually pretty powerful. And then if we have some time at the end, which I'm hoping we will, we've got a little machine learning demo that connects to all of this as well, which is a very exciting and cool evolving industry that I think is going to play very, very well in the kind of data that you all are collecting. And I should say, that although we'll be talking about Microsoft Azure, I don't work for Microsoft, I'm not a Microsoft shill. There's equally good products in Amazon, Google, as well as other private. So I'm not here to sell you Microsoft, but it's the one we'll be looking at today. All right, so one of the IoT devices that we've been playing around with a little bit, not as like a commercial product, but just to kind of get an idea of how it all works from the data management, is the little Raspberry Pi. So this device right here, see a picture of, I actually have one up here. It's wired onto a little demo board. We've got a little pressure, temperature, and humidity sensor on there. The Raspberry Pi itself is running Windows 10 IoT Core, so it's basically an embedded version of Windows, but you can run Linux on this as well. And you can write in Python, you can write in PHP, you can write in whatever you want. It has a gigabyte RAM on this little motherboard right here. It's got 4-core processor, it's got HDMI, Bluetooth, Wi-Fi, USB. You can actually you can actually use this as a desktop computer if you want. It wouldn't be very powerful, but it's got all of the equipment to do it. And it's $35. Right. I think back when I bought my first PC, which is many, many years ago, back in the late 80s, I think I spent $2,500 for that thing. It was a beast, and it was probably 100th of the power that this thing has today. On this motherboard is a little $19 pressure sensor. We have this experiment. If it was working, it would be awesome. We'll tell you about it in a little bit. But we roll a little piece of code, we run it on this thing, and it actually gathers the data off of the sensor, and it connects to Microsoft Azure, the cloud, and it pumps messages like every 5 seconds to something called IoT Hub, and maybe Chris can navigate over to it right here. So we've got the little sensor right here connected to the Raspberry Pi 3. The reason we can't actually run this today, I wanted to show this to you, is that this group requires Wi-Fi, and the hotel here runs a proxy server, which requires you to type in that little code, and probably we're all doing that. So this can't handle that. It doesn't know how to deal with typing in codes at hotels. If you want to see it, come down to Sitka downtown. We'll plug it into a straight IP network and it'll work great, but not so much here. So these messages, they pour out of these things, so you can let them to do whatever you want. They land in this thing called IoT Hub in Azure. Now, IoT Hub in Azure is sort of a distribution point for messages. So you can deploy tens of these or even thousands of these. It scales that big. This thing right here acts as a message repository, and you can connect things to it. So you can have listeners that are looking for data feeds to send out emails, or looking for variations in temperature that could indicate an out-of-water condition, might generate some alert to somebody to do something. They have this other facility here in Azure called Stream Analytics. So it is a subscriber to IoT Hub, so it gets all of this data off here, and it allows you to do reductions. So if we have like IoT Hub here, this IoT sensor that's actually spitting out messages every 15 seconds, that can get to be quite voluminous when you have thousands of sensors out there. Stream Analytics lets you say, okay, listen to an hour of this data and give me the average, or give me the moving average of that data. And that spits out stats that can be used in other applications as well. So you've got this in-stream way to query and reduce the data rather than having to store terabytes of data and run kind of complex queries. A fundamentally different way of thinking about it than SQL databases and big queries. And this would have been the project we would have shown you today. Was the streaming dashboard. It would actually have a real-time graph that would be running and updating every 5 seconds. Yes? Imagine a nice squiggly line right here. And then I could actually, we do this at conferences all the time, actually. You put your finger on the sensor, and then within a few seconds, you see it spike. So we really do need this real time. So sorry about that. It is a demo, so you gotta have one failure. Okay, so hopefully this one will go a little bit better. We're going to show you a little bit about some of the analytics that we have wired up to Azure and GeoOptics. So GeoOptics is our data management platform. We're going through a major revision of it right now. We'll be around next spring, commercially. And maybe, Chris will bring this up. So it's currently in use. We have right here, this is our field browser application, which field crews use. This is a particular site in the John Day watershed that was done in 2016, I think. So there's a whole bunch of data about this site, and it's all stored here in one kind of place. We've got temperature readings for air temperature, photos, scanned pre-performed, solar input measurements, and then we have these screen temperature readings. So all files in GeoOptics are exposed through an API. Right, so if you're familiar with what a web API is, web API is basically a browser for machines. So rather than hitting something in the URL and getting HTML back, a web API is you hit that URL and it returns something back that computers don't understand. So we built an API on top of this platform that makes it possible to do integrations from anywhere, including the cloud. So what we're going to do in this demo, Chris is going to facilitate it, is that we're going to simulate like when a file is uploaded in GeoOptics, it publishes an event. It says, hey, there's new data here. And you can actually subscribe. We have little pieces of code running in the cloud that listen to that event. When they hear it, they can fire up automatically and do a bunch of computations. And so in this case, that temperature file, when you upload the temperature file, there's going to be a message fired, and Chris is starting that right now. He's simulating it with this little node script that he's running right now. So that's actually kicked off a little process of a function app in Azure. It's written in Python. It's actually reading that file and doing temperature calculations. It's actually doing a pivot by date so that we can actually have a nice visualization that we'll show you in a little bit. So that's actually running now in the background, isn't it?
It'll pick it up in a second.
It'll pick it up in a second. I have a 100% guarantee of that. Okay, so without that, it's kind of be hard to kind of go on. This, yeah, the suspense. He told me there would be no more. We don't have one failed demo, so like we're at our quota, the first one. So the thing about app functions in Azure, they are called lambdas in AWS, but these work. You can actually write these in any language. Pretty much any language you want. So this one's written in Python, but you can write them in Node. You can write them C#. You can write them in F#. I think PHP. So if you have programmers in your organization that have any level of programming ability, some languages, there'll be language there.
Can you rattle off a few applications of using the Raspberry? Like I think we had a refrigerator fan. It was sending out temperature readings, so we made sure our trees didn't get too warm. That was one application.
Yes.
What are some of the
Well, we don't do a lot, so the question was, what are some of the applications that you can use for a Raspberry Pi? I mean, we don't do a lot of that sort of field work in terms of we're not hardware people necessarily. But I mean, I showed you that list of sensors, right? I mean, they've got raindrop sensors, of course, kind of the standard weather, temperature. They've got motion sensors, distance sensors. Thank goodness that's working. And so just about anything that you can dream up with. I mean, the big thing is you need to have source of power. These things draw about 10 watts. Right? So if you're able to get some of that, I think you can meet that probably with a good solar panel, so it's got a low power consumption. And you also need, of course, connectivity, which is tough to do. But I mean, anything I mean that we could imagine. I mean, these things can be deployed in the thousands, right? And all of that data can be stored up in the cloud. It is stored up in the cloud. Microsoft's not the only one doing this, obviously. There's a lot of commercial companies who you probably hear them on NPR all the time, and then we move around here. A lot of commercial platforms that do this work as well. So right now, this script is actually running. Hopefully you didn't have to kick it, it just took off. Okay. So what it's really doing is it's consuming 366 days worth of temperature data. Actually, no, more than that. It's like 3 years, and it's consolidating it down to a day of the year. So we can actually compare, for example, 2017. What was the weather or the temperature doing on April 1st of 2013 versus April 1st of 2014 versus 15 versus 16. So it kind of gives us the ability to kind of do some of that higher level, making information that might be useful for answering a particular question. And so we'll let this cook. It takes a couple of minutes because it's got a lot of data to grind through. It's done. Thank you. So what we're going to do now is that we've actually just computed that all of those calculations were stored back into GeoOptics. So GeoOptics has a structure where you can describe data in any form you want, and then you can actually access that structure through an API as well. So that Python script grabbed a data file, a temperature data file, did some computations, and actually stored back the results in a structured format. We're going to use that format right now to do some visualization. So here's that function we just looked at, the temperature file, and now we get kind of a tabular structure, if you will, sitting in GeoOptics as a result of that. I think Chris had a Postman. Do you have a Postman example of that, Chris? So for someone who's actually interested in seeing what a RESTful web API looks like, what happens when you actually make a request and you get data, Chris is this is a free tool called Postman. Used for testing. The internet here is not super fast. That'll be running, and that'll kind of give you an idea of what the data looks like when it comes out. In the meantime, because that can take a little bit. What we're going to do is we're going to show you how you can visualize some of that data that we just created in a tool called Power BI. Now, who's heard of Power BI? Show of hands. Okay, great. All right. So Microsoft has got a BI, or business intelligence offering, that kind of rivals Tableau. They have their own substructure and pricing and all the rest of it. It's got a lot of great capabilities. The desktop tool is free. Anyone can use it. But if you want to publish your reports on the web or do other things, that's when they want to talk to you about credit cards and all this kind of stuff. But for our example today, we're going to use this to show you a little visualization. Microsoft has this SDK that they publish, which allows you to build open data, or data connectors built on OData, the OData standard, or a RESTful API standard. We built a little adapter right here so that new data that's in GeoOptics, Power BI can just connect to either from the cloud or from the desktop. And Chris is showing you that right here. Please click if you're familiar with Power BI, you can do a click get data. And here's our data connector, which we just did for sample purposes here. And he's got it connected in. And so if I'm not mistaken, I think you can just do a refresh. So we've built a little data model for this ahead of time, so we can make that along in the demo. But to refresh the data, all you got to do is click that button, and it goes back, and it's now querying GeoOptics, that web API, pulling all the metrics out of there, and refreshing the model here in this Power BI solution. And that shouldn't take. The internet here is a little bit slow, we have noticed, so this will normally be done by now. There's data. This would be where I would have a good joke, but I wasn't expecting this.
Can I ask a question?
Sure, while we're waiting, why not?
So GeoOptics, so Azure, like out of the box, doesn't run code. And GeoOptics, is that the big add-on of GeoOptics? Is that the run code there?
Yeah, GeoOptics is our product, so this is we're going through a major re-architecting of the platform so that it's going to be in Azure from the get-go. Right now, it's an on-prem solution, which kind of increases the cost and makes it a little bit slower to have people adopt. We want to make it in the cloud, and so that it's really just a couple of clicks and you're up and running, and have infinite scalability, right? Because these API, as an example, we fired up this API, and we have quite a bit of work that we do with customers already that work in the cloud and do a lot of these computations. Some of them are GIS-related computations. Some of them are just straight calculations, hydro models. So we do a lot of Delft. Folks who work with us do a lot of Delft modeling on some of these things, and it all runs in the cloud. And you want to, because those are computationally intensive things, and you want to just spin them up. Well, one of the first things they did was, let's spin up 80 servers or 70, 80, 90, 100 servers, all running simultaneously, hitting this one endpoint that was trying to serve data, and it overran, right? And so we're like, okay, well, wait a minute. The problem here is that, we also need to be in the cloud to be able to make that sort of thing work as well. So we'll scale up. So when we get tons of load, 100 servers, 200 servers, 300 servers, we can scale up and meet that load, and when that load dies down, our stuff will go down as well. Right? So that sort of approach and platform is common in the cloud. It's harder to do. It's more expensive to do on an on-premise solution. So that's one of the fundamental reasons why we're shifting. Is we think this sort of integration, these APIs, this is the future, right? How are we doing, Chris?
It's loaded.
It's loaded. Okay, so Chris has got the data model refreshed, and he's got these are calculations that that little Python script that we showed is actually running. And so what Chris is doing is just creating a simple little visualization. I think we wanted to do it with the line chart, but that's easy to change. So all he's doing here, this is kind of the sweet part about Power BI, is that if you have your data model built and you got it connected and your data is refreshed, super easy, right, to basically create some visualizations here. So what Chris has got done, he's got the temperature average by day. So this is by day of year. We're 14, 15, and 16. These are the three graphs. That is a very odd looking.
Yeah, it's sort of
Sorted. Okay. And so this is from a tidbit probe in a stream in John Day that sat there for a few years. It was harvested in 2016. Now we've got the data in here, and we're able to play with it in any number of ways. So this is pretty cool, and it only took just a few minutes, right? And this is all of the visualizations that are up here. If you don't like the visualization that you found there are dozens more for free on the Microsoft Store. And if you don't like those, you can write your own. There's an SDK that's open. You can build your own visualizations. You can actually integrate plots from R. So if you guys have got fans of R, you can integrate R into this as well. And there's a ton of investment. I was at a conference earlier this year at Microsoft, globally focused on BI and Power BI specifically. They are spending millions of dollars on this platform right now. So there's going to be continue to be lots of advances over the years. So Chris, we're getting along here. Why don't we do this? The next kind of example I want to show you is like how we share this. So great, we got a visualization. We think this is helpful in a micro sense, but we want to actually share this with others in our organization. So that little button right there that Chris has got here, just this little publish button, he can push that. So save as changes first. And now what this thing is going to do is it's actually taking this entire solution, it's putting it up on the web in Power BI online. And anyone who's a subscriber to your organization, so like if you're an agency and you have a Power BI subscription from Microsoft, anyone in the organization can have this app, this function, or this visual distributed to their desktop. And if you have another license from Microsoft, you can actually put this on websites that don't have any Power BI subscription. So if you want to just share it genuinely to the public, you can do that as well. And so there it is. I don't know if you have that, Chris, but it would be great to show that if you could real quick. So now he's actually using a web browser. I'll show you that in just a second. We'll move along just because we're going to run a little bit short on time. Sure.
I have a question. When you kick this off, you mentioned how only about 0.5% of everything we have is actually usable knowledge. We have a lot of data out there that's just not being used. And I was hoping you'd come back and give us some best practices or some standards for converting that information into usable knowledge and intelligence. Do you have anything you could share with us that you see as kind of standard best practice, regardless of technology that you're using?
So the question was, are there best practices around how to turn the data or information into knowledge? I don't have a magic pill for that. I think, part of that is the whole bit about having a knowledge management strategy session and really kind of focusing in on what are the key decisions, right? Oftentimes we get into these notions of like, well, we know we need to collect this data because we're just expected to do it and it's always been done. And we often find folks like, well, how is that data actually leading to changes in your program? I mean, you're learning something from this and you're adapting what you're doing. You're ceasing certain things and you're doing other things, right? Well, no. Well, then what are you doing this for? Right? It's not actually tied to a change or some sort of adaptive management feedback loop that you're looking to see whether your expectations are being met. If it's not tied into that sort of decision-making framework, then stop doing it unless it's just a long-term status and trends thing where you just need to report on it every once in a while to a regulator. So I think there's a little bit of inertia that people get into because something's always been done that way, and like this strategy, this approach really dictates you stop, really break down those questions, and there are consultants out there that can help you, do that to really get to the gist of what it is that you're trying to answer and what data is really actually required. So I don't have the single little nugget there for you. It's really more of a process than it is a nice answer with a bow on it. So.
Just kind of, just to add to that discussion a little bit, I mean, I would say just data exploration, could be done more. Even that Power BI tool, that thing can connect to so many different databases.
Oh, yeah.
You could just go to a public database and bring in weather information.
Yeah.
So if you wanted to combine air temperature for that chart, it'd be very easy. And just to be able to play the data and for discovery purposes.
Yeah, a lot of it is exploration.
And one of the concerns I have when you have these powerful tools, if you're a project manager making a decision about how you're spending money on your project, you have to know what to ask for that data, because whoever is getting the data can give you all kinds of things here, but you don't know what you're asking for.
Yeah.
Or you need it.
Oftentimes you don't know what it is that you want until you see it either, right? And so that's been the trouble with classically the way that IT has worked is okay, you want this new thing, it's going to report great. Write us a requirements document. We'll get it in the budget cycle, and maybe you'll get it next year. And you're but then when you get it, you're that's really actually not all that helpful. I mean, if the data is open, right? Our philosophy is if the data is accessible and open to you, then you can play with tools like this, and you can actually discern what's relevant, what's valuable, and what's not. And if you want to systematize it at that point, now you've got something you can come to IT with and say, yes, I want this visual and this dashboard to go out everywhere. So yeah, having the ability to do that, to play with it, experiment, iterate is critical. We're actually using this tool in our own company for our own metrics, right? How we manage the business, and it's pretty powerful. So the last little demo I have, and I know we have very little time, so I'm probably not going to do this one justice. As a matter of fact, this is the deepest topic in the presentation, and so I'm not going to be able to get through a whole lot of it. Before we jump to that, though, I did want to point out that Chris actually did pull this up. So this is that same temperature report that we looked at on the desktop, in the web. We can share this with any of you at this point. So it's a great way to disseminate information that you harvest it. And we did all of that off of a field survey in 10 minutes of time. Okay, so switching over to machine learning. So how many are using machine learning or really want to in your programs? Anyone?
Say that again.
How many people are actually using machine learning approaches in your environmental programs or want to? Wow, okay. How many know what machine learning is? Okay, all right. So, machine learning is in essence I think it's the piece that gives us the ability to take all of that data, which has got a lot of noise in it, and be able to discern the signal, right? So we're really concerned with separating the signal from the noise. And because there's so much noise and so much data, we can't do that as human beings in classic functional approaches to things. We need algorithms that learn and can digest reams of data and hopefully give us some guidance on what's actually happening in the data. So machine learning is kind of concerned with that subject matter. It's a very deep subject. Lots of people do it in the field right now. I'm not going to do it justice. Microsoft has a machine learning solution in Azure called Machine Learning Studio. And it can connect the data in geooptics, not surprising, but here's all the other data sets that it can connect to, and there's some others in here. So Azure Table Storage, so Azure natively stores tables, kind of like database tables. You can do all of those. Excel, SQL databases, had to fit through to like really big data solutions. You know what that is. It can connect to any old RESTful API that you want to connect to. You might have in your own organization that can actually ingest that, as well as what we call document databases, which are schemaless, NoSQL databases. So lots of different ways to get data in. The 4 basic steps for creating machine learning models are data preparation. That's obviously most important, and actually takes probably most of the time, because getting clean data, knowing where you got it, and being able to integrate it with others, that's the really difficult part. We need to do some algorithm selection. So machine learning algorithms are generally clustered into a few different categories. We got clustering algorithms, regression algorithms, and classification algorithms. And I may not have a chance to show it to you here today, but I invite you after we're done, come over to the booth, and I'm happy to walk you through some of the models that we've built using habitat data from the John Day. We were able to actually do some regressions and some data cleaning and do some model evaluations, and I can show you this. I think we do have enough time for this. Once we have this model trained on the actual data, so we do this training piece where we actually take the data, it comes in, we train the model on it, and it actually understands the relationships, and it's multivariate. So it's not just a simple, two-dimensional. It actually looks at the strengths of all the indicators or all the features, picks the ones that are the most predictive, and then the right combinations, and then builds models that allow you to do predictions on it. So you can actually take these predictions, these models, publish them as a web service in Azure, click of a button, not quite that simple. Now you've got this engine sitting in the cloud that you can, using any programming language, you can do it from back with those little app functions, remember that Python script? You can actually make a call to this app service from even in that little Python function to do a prediction. So as a base set of input variables, we can actually make a prediction about the thing that we care about and integrate that into our cloud offering as well. I built a couple models based on some habitat data. They were really crooked. They were really bad. I think I got an R-squared or something like 0.18. So not a great model. I don't plan to be a model builder, but I can tell you that I use the tools to produce them. So, but we have the last thing we want to show you here today is that we have an R script. So for you folks who are familiar with R, we published this model earlier this week. This is the code. If you've written R, this is what R looks like. And what this is doing is it's applying several input values here, and what we're trying to do is predict large wood frequency, or actually large wood volume in a chunk of stream based on lots of other characteristics about that stream, which, as it turns out, are not great indicators. If you were to look at the box whisker plot, I think over half the data set is considered outliers. So it wasn't a great selection, but we can all put one together. So you want to run it there, Chris? You can see it. Here's the console running down there in the lower left. And so we see right here, here's the model that ran all these inputs up here. And so we've got a sort of the mean of 7 cubic meters with a standard deviation of 14. So pretty much covers the entire universe of all the possible wood combinations of the Columbia Basin. But again, we wouldn't, this is an example or not something we want to do. So that is machine learning in a nutshell. And I'm happy to actually walk you through the model. I'll be out there for the rest of the day. Had a boss, we'll wrap it up here, I had a boss once, my first boss, who said, whenever you're in a presentation, do 3 things. Tell them what you're going to tell them, and tell them what you told them. And so, in honor of my first boss, this is my tell them what you told them slide. key steps here, obviously, what takeaways we want you to have is make sure you understand truly the decisions that you're trying to make a plan, right, about how those are going to be made and what's needed to get them done. Align your systems around those needs. That often gets missed, obviously, and when it's missed, you're making decisions that are not based on best available data, you're making them intuitively or out of habit or some other thing, things that we want to discourage in the science field. Cloud can help. There's a lot of data out there available. You're going to potentially collecting a lot of new types of data. So think about when you're lining your systems and your strategy, what role does the cloud play, could it play in that strategy? And get started. I mean, I would love nothing more than for this industry to kind of take up some adoption of these newer technologies and start using them to solve some of the more complicated problems. I mean, this is a complicated field we're in, right? The science and the number of variables that are involved are hugely complicated. The tools are coming online now where we can actually start on those at rates that were not possible before. And I would love to see us serve ahead and kind of follow the footsteps of our for-profit brethren that build all this so that they can track chemistry sales. But I think they can help us too. I'd like to see that happen. So I think that's it. I'll be around, as I said, in the booth. I don't know if we have any time for questions. We have 1 minute for questions. Is that right, Dan?
Yep, just 1 minute.
I've got one question.
One short question.
Short question. All right. Well, thank you, everyone.